Apologia, 8th grade, Physical Science, Week 13, Day 3, textbook pages 214 to 215, notebook pages 171 and 172. Graphing acceleration. Just as we were able to graph velocity, we are able to graph acceleration. Suppose a biker is biking downhill in a straight line and the bike's speed increases 2 meters per second every second. That means that the biker's acceleration is 2 meters per second, or 2 meters per second squared. This figure is a graph of the biker's speed over time. This is a speed time graph, and the slope, the rise over the run, the slope of a speed time graph is the magnitude of acceleration. Remember that the mathematical definition for acceleration is change in velocity, speed if it's a straight line, divided by the change in time. That is what this graph describes. So this graph is positive acceleration. The slope of a speed time graph indicates acceleration. An upward slope indicates positive acceleration. Let's say our biker, after increasing speed at 2 meters per second for 6 seconds, starts to coast at a constant speed for 3 seconds. Then realizing he's going too fast, so he begins to slow down at 3 meters per second until he stops. What would the graph of that acceleration look like? All right, so let's look at this. Notice the positive acceleration indicated by the slope of the line from 0 seconds to 6 seconds. So from 0 seconds to 6 seconds, from here to here, we have a positive slope. Then when the biker was coasting at a constant speed of 12 meters per second, the line is a straight horizontal line. So here, he was coasting at 12 meters per second. So coasting right here. So there was no acceleration on that segment. That indicates that there was no acceleration during those 3 seconds because neither the speed nor the direction was changing. The biker was still going downhill. Now look at the slope of the line from 9 seconds to 13 seconds. So 9 seconds to 13 seconds. That line segment is sloping downward, which represents that the bicycle is slowing down. The change in speed is negative, so the slope of the line is negative. So from this section, section A on your notebook, we have positive acceleration. Here, we have no acceleration. He was just coasting at a constant speed. Here, we have negative acceleration. He was slowing down. What does acceleration look like on a distance time graph? Remember that the slope of a distance time graph indicates speed. When an object is accelerating, the object's velocity is constantly changing, so you wouldn't expect a straight line. Remember that a straight line on a distance time graph means the velocity is constant. It turns out that accelerated motion shown on a distance time graph is represented by a curved line. This means it is a nonlinear graph in which a curve is used to connect the data points. So let's look at this figure 6.20, and that shows a distance time graph for a car starting from rest and accelerating for 8 seconds. Compare the slope of the curved line during the first second to the slope of the curve during the 7th second. Okay, so when we're looking at seconds, here's our first second. We're comparing this slope to our slope at our 7th second. Notice that the slope is much greater during the 7th second than during the first. Because the slope represents the speed of the car, an increasing slope means that the speed is increasing. An increasing speed means that the car is accelerating. All right, on your own. What shows acceleration on a speed time graph? You should know this. I think I've said this like 4 times on this video. The slope of the line on a speed time graph shows the acceleration. All right, summing up. By now, you should have a good handle on describing motion. This is important because most of physics and all of science is concerned with motion. In the next couple of modules, you'll learn about what causes motion, forces, and the scientific answer to why motion occurs, energy. When you take physics in high school, you will go into more depth in your understanding.